Hi, everybody, and thank you for joining me for this session. I'm going to be talking about Oracle's Government Cloud and how we bring the world's most important work to OCI. My name is Rand Waldron. I'm responsible for everything that Oracle Cloud Infrastructure does for governments globally. That includes our government regions in the United States, our government regions in the United Kingdom, and our disconnected, air-gapped regions, our national security regions, that bring full cloud to disconnected national security networks. Really, I have one core point to make in this entire briefing, and that is that the work you do, the work we do as government professionals, is the most important work in the world. And when you bring it to cloud, you shouldn't come to cloud thinking, well, there's a vendor, there's a known destination, and I'm just going to force my application, my program into that destination. Even if that destination is Oracle Cloud, of course, I would love it if you sat there and decided you were going to move all of your systems to Oracle Cloud. That's a great idea. But really, my point is to look at your systems, look at the work they do, and look at how they do that work, and find the cloud that fits that system best. Clouds are not a commodity. Clouds are not one size fits all. You wouldn't take your foot and make your foot fit the shoe. You would find a shoe that fits your foot. And that's what you should do with your systems. Every system is different. Every system's mission is different. Every system's architecture is different. Find the cloud that fits your system and your purpose. So this really is at the heart of getting into cloud. We all know we have to get to the cloud. We all know that the innovation we need is there. We all know that the cloud brings reliability. The cloud brings the ability to escape our on-premises data centers. The cloud brings so many good things, but it's hard to get to the cloud. One of the biggest reasons it's hard to get to the cloud is because the clouds that are out there, the clouds that we have worked so hard to get our systems into, don't always fit our systems. And so one of the ways to make it simpler is to pick a cloud that fits your system. So when you look at cloud, you're looking at a world where cost and architecture are deeply interlinked. So on premises, you buy a couple of racks of hardware, you deploy your system into it. And once you've bought that hardware, as you deploy into those racks of hardware, your cost doesn't really vary all that much. Maybe there is some micro cost that somebody in your government agency feels if you burn a little bit more electricity or a little bit less electricity with your CPUs. But there isn't really a deep connection between cost and architecture. That's not really the case in cloud. In fact, it's the opposite. In cloud, every single choice you make in your technical architecture has a direct long-term impact on what your cost is going to be. And so as you start to look at your system, as you start to look at cloud, look at how each cloud provider treats different parts of your system. Every cloud provider has built a technical architecture and has built a financial model that encourages certain behaviors on the side of their customers. If you're looking at a cloud provider and you have a piece of technology that you use at the core of your system, you look at that cloud provider. Some cloud providers will make that a really cheap thing. Some cloud providers will charge a lot of money for it. Some cloud providers will make the innovation you want hard to get and more expensive, and some will make it cheaper. That'll all vary based on the kind of system that you're bringing to the cloud. So look at that cost, look at that system, and look at the financial model of your cloud provider. This is just one easy example that we use at Oracle with a lot of our customer systems right now. Bare metal. So Oracle Cloud Infrastructure is famous for its bare metal solution. We bring an incredible amount of control with literally no hypervisor, no Oracle controlled software on the server, and we make that completely available to our customer. That means you can bring an on-premises system right into the cloud. You don't have to go through months or years of re-engineering to make the system cloud native. You can bring it right into the bare metal environment. You can use our layer 2 networking, and your application won't even know that it's in the cloud. It feels like it's on premises. truly, what makes that impractical in many of the other cloud vendors is the financial aspects of it. That sort of move and improve, or God forbid, lift and shift migration process is financially almost impossible in other cloud providers. And so you end up in a sort of a big bang release where you have to re-engineer your system. You have to break up the monolith and put the system into the cloud while you're doing a large-scale cloud migration. So you're putting off new feature delivery, you're putting off serving your mission because you need to re-engineer your system, all because just moving your system into the cloud is financially impractical. Well, at Oracle, we make that financially practical. Our bare metal solution is considerably cheaper than our competitors. This is just one example. There are others. There may be others where Oracle's more expensive. There may be others where we're even cheaper than the example here. But this is an example of how you can understand your architecture, you can understand the financial model of the cloud provider, and you can understand your migration path. Hey, having cheaper bare metal makes it easier to move into the cloud quickly, and then over time, re-engineer your system. So you can take advantage of cloud services immediately. You can get out of your data center immediately. You don't have to go with a re-engineering first process. Great. That little pricing architecture, that little pricing model differential can change how you look at your migration to cloud completely. A good example of this is DMDC, the Defense Manpower Data Center. And so they've moved their human resources management system into OCI, and were able to move it into OCI bare metal very, very quickly for a very reliable, highly secure solution that got them out of their data center, got them with more modern hardware, more modern software, and then immediately gives them the ability to extend that solution with other components and capabilities of the cloud. The state of Texas did something similar. They moved their entire system into Oracle Cloud, started out with a very, what I would call standard lift and shift, except at a massive scale. They moved it in using bare metal, and then over time, they can break up the monolith, they can upgrade their system, and they can take advantage of some of the other services around it. But all that makes sense in a place where bare metal has an efficient cost rather than other cloud providers where it doesn't. Big data, when you look at government systems, they all have an immense amount of data gravity, where there's a tremendous amount of data in one system or in multiple systems, all working together in order to deliver either mission impact or deliver citizen services. And so what we do is we bring that sort of big data management, that data management capability that Oracle is famous for and has been famous for 40 years, and bring it to the cloud. But we also bring it all the way out to the tactical edge with our roving edge infrastructure. And we bring real data analytics that are rooted in a suite of big data services based around the Oracle database, but also open source databases, data science and analytical tools, AI and ML, that all allow you to tackle this big data environment and deliver better results to your citizens and your mission. This is an example of that data lakehouse concept. So you have that immense data gravity, you have that data, you want to actually use it to deliver better impact to your mission consumers. You can do that by creating your own data lifecycle, where you collect data from multiple sources, you extract and transform and load it into analytical systems. You use data science and ML platforms to build tools to analyze the data and extract intelligence, and then you push that out to your customers. Assembling that all yourself is incredibly complicated. What Oracle Cloud brings is all the pieces of that already integrated and tied together. So we have data sources. We have the ability to extract and manage data from almost any data source, from our databases, from other databases, from open source databases, even from other clouds, and from the Internet of Things, from events and sensors. Then we have processing engines, we have a data warehouse, we have the ability to move, tag, label that data, and we have AI throughout these services to make it simpler to configure and to actually extract the value from these services that you need. And then on the final outcome, once you've taken the data, you've used the services to label, to make it ready for use by your end customers, we have a set of services that allow you to do that much more simply. We have Oracle Analytics Cloud that takes that data, really puts it in a highly visual, highly usable, highly scalable, and repeatable format for thousands of customers. We have an incredibly powerful data science application that allows you and really your data scientists and your analysts to collaborate as they extract insights from that data. Data science tools allow you to take that data, allows an analyst to set up an environment, allows them to configure their Jupyter notebooks, their other pieces in as clean a way as they can, and then share that. Allows them to create models, share the insights from those models with other people, and then use that in a way to scale, publish, and make something that's consumable by hundreds or thousands of people who aren't data scientists and analysts. CERN is an example of where we did this. And so CERN took microservices and Kubernetes built around the autonomous database and allowed them to monitor more than 2 million signals from the Large Hadron Collider. So the Large Hadron Collider is like one of the coolest things on the planet, tens of kilometers underground in Switzerland and France. And it has literally millions of signals generated on a minute-to-minute basis. And this is analyzed, displayed, and made available to scientists through Oracle Cloud Infrastructure. One of the things that make it simpler for governments to get to cloud is to really understand how security works in the cloud. And any cloud provider will tell you that they are very secure, that there are essentially no breaches of their cloud, of the cloud. They've made their system very secure. It's very hard to distinguish at the level of a PowerPoint presentation where reality is versus just the talk. Here's what I'll take and what I'll bring forth in terms of what our opinion is on this. Very rarely are our customers, are any customers in the cloud breached because they don't have the tools or because the cloud provider had a fatal flaw in their cloud. They get breached because all of the tools, the configurations, the interactions between all of the services are simply too complex. And there is no way for any customer, even a security-wise customer, even somebody who knows what they are doing, to be absolutely sure that they have configured every service correctly, that they have configured every piece of their virtual network correctly, that they've configured their identity correctly, and that they've done that at scale across their entire estate. It's simply too hard and too difficult. And so we've built a set of security tools that make it much easier to do this. We've built a set of security tools that aren't around the idea of how many different switches can we give a customer. They're built around how do we start secure? How do we make them very easy to use so that the customer knows what they're doing and as they change their configuration and how that configuration changes their entire security profile. We've tied all of these pieces together with deep integration and monitoring so that your security tools connect very directly to each other. You don't have to figure out how to manage them, how to wrangle the APIs, and how to do all of that. We have the monitoring that spans your entire estate so that you have tools like CloudGuard, security zones that show you exactly how your estate's configured, what's working and what's not. And we have deep interoperability so that you don't have to figure out how to integrate with your other tooling yourself. Our tools help you integrate with what you already have and with amongst themselves. We really come at this in a very prescriptive way. So our security principles are to make it easy to use, to make it very transparent across your entire enterprise estate as to what is happening and how it's happening. We come up with a very prescriptive opinion. This is how we think you should configure your environment. You can absolutely change it, but we're coming with a prescription so that you know what your security profile is, why it's that way, and then you're changing it very consciously. We make it very automated so that this can be updated and managed on a regular basis, and that you don't have to feel like it's your job to be in it all the time. And we unify it. All the tools tie together and work together. Really importantly, we've taken this layer of security tooling and we've made it very cost effective, which effectively means we've made it free. In almost every case, our security tools have no additional cost. In some cases, there is a cost because they integrate a third-party system like Palo Alto or something like that. But essentially, we do not take our core services like storage and then add layers of security cost on top of it. So what starts out very simple and very cost-effective storage becomes very expensive by adding multiple layers of security on top of it. Our security services come free and they don't layer on top of those storage services. This is one of my favorite examples because I think it hits close to home for all of us. And that is, we deployed an entire COVID vaccine management system called vSafe with more than 10 million registrants, over 140 million health check-ins, and hosting more than 1.2 million active users for the US government in less than 10 days. That was done because we have the tools that allow that security to be deployed very quickly and allow the code and the data stores to be built very quickly. You bring the two together, fast security, fast development, and you're able to build massive applications that deliver mission impact right now. In the end, what this all comes down to is we can bring our cloud services, our differentiated pricing models, our differentiated services. We can bring our security and our capabilities for data science and big data analytics, and we can bring it to you into multiple deployment environments. So if you look at our big public cloud, that there are hundreds of sessions here at CloudWorld talking about our commercial cloud environments and the almost 40 regions we have globally right now. But we take that exact same core infrastructure and we use it to build our government regions. So our government regions don't have a different infrastructure. They don't have limitations in terms of what Oracle or OCI services and capabilities can be deployed into them. We bring that exact same core set of hardware and capabilities. We deploy all of our services, something called Everything Everywhere, into our government regions. So our government regions are the exact same as our public regions, just with enhanced compliance. We can do that same thing, that same base cloud structure that we deploy into our commercial environment, that we deploy into our government environment, also into our dedicated regions. And that's where we can take an entire cloud region and put it in your data center with your services managed your way so that it is close to your existing infrastructure, close to your existing network, close to your existing systems, and it's in your facility if that's important to you. And then we can take that exact same footprint, that same base infrastructure, that same capability, and we can put it across an air gap for our national security regions. We take every capability that is in our public regions. We have a policy to bring every single service across the air gap into our national security regions. So our air gapped regions aren't sort of a limited version, a subset of our cloud solution. They are our complete cloud solution, but available to government customers across an air gap where defense and intelligence developers and customers and mission users can use the cloud in the fully secure way they need. And last, we take now a subset of that and we put it out at the edge, something we call Oracle Roving Edge Infrastructure. So this is where you can take something that is as small as in my hands, called our Ultra device, or as large as man portable, or as large as a container. and use it for a subset of our IaaS services. Build it in the large cloud regions that are to the left here, and deploy them into the roving edge infrastructure, and then take that wherever you need it to be, from as small as fits in my hands to as big as a container. Move it wherever you need for distributed use cases out to the edge, and in many cases, really out to the tactical edge where it's being used by defense customers today. And that's it. I just want to thank you for your time. Please take some time, reach out to me and my team, and we're happy to describe more about what Oracle Cloud Infrastructure does for governments. Thank you.